Welcome everyone to more live Linux distribution development. The only constant is change and regressions, and everything obviously is complex. I can't believe how many people it requires and days and changes actually to get LLVM Clang extra tools to work. Contributing developer Notec recently enabled it in LLVM. I fixed it already a little bit, but like even with my fix, now it still doesn't cross-compile, right? Like how many developers needed to integrate LLVM Clang thing? So the stupid thing is that now, like all builds, and the thing, so I test builded that maybe on x86 and that probably built. And that's the thing, right? What you didn't test is broken. Like if x86 kind of pseudo cross-compile because it's the same hardware, but like cross-compile bootstrap, so basically completely clean, decoupled without system C library and stuff, because potentially different C library, right? Like even x86, glibc to Musel or other calling conventions and stuff, and even different glibc version, right? Like if you just would link in the system library, you might end up with different symbols, different version symbols, and so on. So this is for native cross-compiled, like cross-compiled, it accidentally builds. For all other builds, that's, yeah, what's not tested is broken, right? Like if you don't test real cross builds, and real cross build is broken. Like all of them, let's take a look at the latest and greatest RISC-V. And so I can't believe it, like 2024, and stuff still executes helper programs, right? So what fails here is genconf exec format error, so it's like, yeah, bin clang tidy confusable chars gen. It's like you had one job, like why do we need to fix all this crazy stuff all the time? So the fix for that is, I mean, the question is, what does it even generate? And so all this stuff always takes some time to review, right? I mean, I could Google that, like what other developers would do is like, does Stack Overflow have something? It's kind of pointless. I usually don't do that. So the problem is it cross-compiles that, like configured, and we have a RISC-V binary, and that obviously doesn't run, right? Other people then at times just run its QEMU, which I don't find the most elegant solution. So how the right fix, or the best fix, certainly high performance fix, is to compile this natively, like we do for other table gen stuff in LLVM and Clang. So as the first thing, we could actually check if, because we actually build a cross-compiler of Clang, so the first thing would be to check if maybe, if we are totally lucky, which maybe we aren't, if we have a cross, do we have here, does this even complete correctly? Okay, we have Clang tidy. We have the Clang and LLVM table gens. Like, yeah, we have like how many table gen helpers? So what they do is generating internal table things. Yeah, crazy stuff. So we need one more of those. So we could either, I mean, the easiest thing, so there are two main things. It's usually you can fix this 100 ways, including running at QEMU, which, so not only is QEMU, in my opinion, like Open Embedded does it a lot or so. I totally don't like it because we don't even have QEMU for all architectures, right? Imagine you port this to some new thing RISC-V. Yes, in the meantime we have RISC-V QEMU, but Long Arch or other stuff, including Itanium, and then you always need a QEMU port, plus performance and so on. So one thing is, so the two main ways, plus QEMU and other quirky stuff. So one thing, the two main ways would be to either patch, quirk, or whatnot, that to natively precompile that, like configure LLVM Clang, and then manually YOLO quirk around there to just build this binary natively, which is what we otherwise often do, or as we cross-compile it anyway, cross-bootstrap, so we first build a native cross-compiler, we could actually save this binary and then and then patch the CMake file to use that, which maybe what we could potentially do first. Alternatively, we could see this is, the question is how complex is the binary. So let's go in there. I hope this should. Darn, I actually built that. That is, of course, as usual. I prepared. I just built this new, but the problem is my auto like continuous integration build things always not keep on error, which probably is the default. Maybe should I mean, maybe I should. I probably so I basically come to the conclusion I lose too much time usually on build error to rebuild that. I guess it's time to change that, because it is just increasingly too time wasting. Keep on error, so that is already keep on error, so basically, yeah, so keep temp_fs on error. I guess it's time to, like, it's wasting too much time continuously not to have the sources, so yeah. As we need to build this already anyway, just a little bit unfortunate now. You prepare for live stream and then, yeah, so is life. Then let's build the zero-stage cross-tool chain Clang, maybe verbose, so that we can better control C that. And so previously LLVM Clang built for us. This is just because we now added this Clang extra tools for tidy, Clang D, code server, and fun stuff like that. And that is also previously why don't we use an IDE, right? Because IDE helps me nothing. Every 5 minutes or 10, every hour at least, I work on some other project, and it's like, these sources are huge, and I need to constantly work with the build system anyway, right? It's not like looking into log files and like, why do you so inefficiently use grep? It's but because I every 5 minutes need to grep through code trees that makes no sense to load into an IDE. Plus, I usually work on Epic, thread ripping, and data center build servers. So it's not like I secure shell through Europe or the world, the rest of the world, here with some IDE nonsense for all those good old-fashioned Unix haters. So that was Clang, that is object dears, it probably builds like that. And now we need to find this table gen thing. That was somehow the confusable table stuff. So that is in Clang. I mean, another quick hack could also potentially be what we also could do, a third solution, which is the lowest hanging fruit would simply be disable that for cross builds. It's like, yeah, for cross builds you don't get Clang tidy. The question is, Clang tidy has so much stuff, so much sources you need for just some Clang tidy thing? Seriously? What even is like in... This is just some crazy. Yeah, I'm also recurrently shocked. Okay, so given that it is so huge, apparently, the question is, where is this confusable misconfuse? What even is that? That's a freaking binary file. Documentation occur. Yeah, in previous times people also would just have used Perl, Python, Ruby, M4, SED, org to generate that. Build is this one here, so I mean, if we are lucky, as this doesn't install, we could potentially try if we just run make in this directory. Maybe this binary is so simple that we can just build it without all the LVM infrastructure. So that is misc already, no, here somewhere. That may be, it did build that already. Okay, it did build this early. Does this have any shared library dependencies? Actually, this has an, does it really use liblvm? That would be unfortunate. Okay, so much to just, okay, I guess I instantly give up on this. What we then do is, it's just install it. Like basically, like, I have doubts. I mean, maybe these are all random as happens in these days, right? Everything just clobbers everything together. Maybe these are not even, they are not even used. Maybe they just link in there due to all the other surrounding CMake stuff. Maybe it just links to liblvm without using it. I mean, we could potentially check with, like if we really wanted to check, we could object dump the symbols. Oh no, you see it is actually, oh no, it has actually LVM. Let's demangle that. No, it has LVM actually, okay, for crazy reasons. So it's using probably not much, but for infrastructure regions, not like normally you would use standard C++ standard OStream, but they use some, obviously some surrounding LVM abstractions. So yeah, so much to quickly building this with GCC. No, it's not like GCC one file. Like what I would do this in like Python, Ruby, Perl, GNU-org, but worst case, if that is not efficient in that for reasons, and some simple table gen thing. But yeah, 2024 software development and infrastructure is not simple anymore. So so this is not installed. So then custom hack that to install that. So that is basically getting an overview. That's the overview. So then, given the complexity of the simple thing, then just install it. So that would be that. What is our bin dir? Does this instantly? Okay, that is not ideal. Okay, that is the root. Some more. Yeah, this might. Yeah, it is what it is now. So okay, root bin dir. So let's install this. So it was in. Did I copy that correctly? Yes. So then let's use an IDE to do the IDE thing of integrated development environment for Clang. Oops. Toolchain, is that not amazing? The future is now. So Clang postmake. We already do here quite some stuff. Probably better program name transform. Yeah. As we have this here already, so we after postmake if toolchain, we either do this first or last. Maybe last. Oops. Use an IDE. They said okay, fine. So then install. We actually, we do that actually. Okay, then, okay, okay, let's group that together. So let's first install the main things. And install that here. I will do that in an extra line. Oops. Okay, this does not behave or I'm used to, but whatever. I do this in an extra line for potentially disabling that, right? So normally you could do this in one line, but as we might potentially, I mean, ideally I would want Clang extra things in an extra package, but it didn't build like 2024. Of course, some extra add-on things do not build freestanding. Maybe it's possible with hacks and quirks and features. Patches welcome, but for today, yeah. So again, normally I would put this together here in one line, but for conditionally enabling this, I intentionally leave it here an extra line. And I usually group this stuff more logically together, right? While it was okayish to have here, I would know that we have a little bit more like copy the main binaries, add here some symlinks, default symlinks things, and okay, there, and then some helper tools and some journal tools for cross bootstrap. Then we need to use it, so we can already build that. So that will rebuild that. Hopefully we have this table gen thing then. Then we need to figure out if they have some provisioning already. Maybe they haven't. For the, how do we do that actually? Okay, let's not trigger people, let's use an IDE. For package again. So table gen. Okay, yeah, we specify that here. The question is, do they have, what was the name of this thing? That was tidy, so that is that. Just let's grab, let's copy that here and let's grab if they have some kind of option to specify that. Maybe even also case insensitive. Setup was tool. Clang, what do they have here? So Clang tidy confusable chars gen, is that? Maybe they have there something. Setup host tool. Clang tidy configuration. Output command binary dir. I mean, maybe that does work. Let's maybe add this. With this modern stuff, it's not necessarily obvious. Oops. Using the wrong IDE. So let's add that and hope it works. I have the suspicion maybe it will not. We might have to patch that out. But let's table gen let's hope that works. It has probably a chance of 80-ish. I give it a rating of 80% to potentially work. Any typos? I typed a little bit fast here. It's always one day I disable non-break because it was one thing I happen to do typing fast. This is constantly. I really hate non-breakable Unicode spaces. It's super annoying. So, Clang tidy configuration gen. Root toolchain tools dir bin Clang. Oh wait, this is also wrong because we copied that. Let's copy that from here. A little bit longish. Modern software development, everything is supersized, including. So this is at the edge, right? So I'm not an 80 character fanatic. It's getting at the problem is breaking. This is a little bit annoying. I mean, even if we break, like, yeah, modern software development stuff, like even that, like, it's shortening this by like 12 characters, right? It's like, yeah. So again, it's fine for me. We have widescreen displays, right? It's fine. We can already build this in parallel. Because we, or did we? Oh no, we didn't. Oh no, we can't necessarily build this. Okay, let's wait this shortly. Unless we manually copy it there already. Yeah, okay, it makes no sense to... how long does this build? It is 13:00, so that build 5 there. It should finish soon. It's building 5 minutes already, so I guess I need to update the cache file also for a build time estimate. Previously it built around 6 minutes maybe on a 79 on an epic thread ripping Ryzen 1750X. Yeah, why do we need so much compute power? Because supersized sources, right? And that is just testing this two-liner. I mean, first of all, it took like 15 minutes to get an overview, and then building this like previously for 6-ish minutes. Maybe now with all the extra stuff, it's more like 8 minutes or whatnot. Probably we need really update the cache file then. This built in 5. No, it's actually not. Actually estimated 6 minutes. It's not that bad potentially. So then there is the so now this is real test. So this was just testing this cross compiler bootstrap to install the yet another table gen thing. I also don't understand, like, if I would write code, I would write it so that I don't need to generate table things there. That it's a little bit iffy to me, but maybe I have different quality and code standards of many other people for whatever reasons. Maybe also because I cross-compile all day long. Anyway, so risk 5. Let's check if it's really there. Nothing like waiting nearly 6 minutes to find out it's not there. So that should be, yeah, now we have Clang tidy. Does it work like this? Clang tidy. It's segmentation faults. That is maybe not ideal. Hello, are you okay? Why did I run that? Does this even use this correct? It uses the correct libdir. I mean, maybe this is so low quality helper code that it segmentation faults when you don't run it. I mean, I guess it did work. It's like 2024. It's like I rest my case. I have no further questions. Maybe it's programmed, it's like, yeah, C++ code quality in LLVM Clang, stuff segmentation faults if you're not run like intended. Maybe it's like it, I mean, my quality standard would be it should not segmentation fault, like even for safe C++ code. But maybe without the right input data, like maybe, I mean, maybe it throws an exception, but what was it? It wasn't an exception, right? Exception would like abort it with, this is so bizarre. What should I say? It's Clang tidy. It's, yeah, maybe it opened a file and doesn't have its. That's the state of 20 years of LLVM Clang compiler research. Helper to its segmentation fault if run not the way the authors tested it. But yeah, I rest my case. What's not tested is broken, even internal Clang stuff. Like, nobody ever tested it to run it with our data file or so, potentially, maybe. Let's hope it works. It's like, yeah, working senior. You work half an hour on integrating stuff and then it's segmentation faults. It's welcome to my life. But fingers crossed, maybe with the right data file in the right location. And maybe it works then, hopefully. Let's see if there's any indication in the log file. Like I usually, like with this long running stuff, and this is modern high performance stuff, right? Until recently, I didn't necessarily had such high performance workstations at my fingertips. It's like, yeah, and it fails. This is why usually I try to test stuff. Just now the build error was faster. I wanted to see in the log file if it did use the right thing. Maybe it's still, maybe it doesn't use that. Where is the error? Recurring theme also that. Where is the freaking error? I hate this modern stuff, so convoluted. Ah, here's some error. Okay, it still runs, so this option, that is what I wanted to check. This option apparently doesn't have an effect that I guessed there. I mean, it didn't does. I mean, usually I'm used to CMake maybe warning that some option wasn't used. It doesn't, I don't instantly see that here. So maybe, apparently we need to patch that after all. That is unfortunate. The problem is the CMake stuff is so complex and convoluted, really not a fan. I'm sorry to say that, but modern complex stuff, not a fan. We had recurring theme, right? We had 12 standards that sucked, and now we have 13 standards that suck, right? What's it? X, is it CAB, whatever, standards. It's like here, probably universal standard, like there were 14 competing standards of build systems and 14 ridiculous, we need to develop one universal standard CMake, like we had make files and automake and gem and who knows what, QMake, and it's like 14 ridiculous, we need to develop one universal standard to rule them all, and now we have CMake and Meson and anyway, now we need to have 15, we need to learn the 15th domain specific language. I only say this because even that can now be annoying to even patch into the CMake files here. Line 80 is this Clang pseudo include. Is this here? Build make, oops. Let's hope it's AT, CD, Clang pseudo, okay. How many are pseudogen? Oh, wait a second. We need more? That is another freaking. I know we fixed, don't tell me we need more bloody. Oh no. Oh, how many helper things do they possibly need? Where is that even in pseudo? Whoa. You can't mix this up, that's just ridiculous. Okay, so to do this more efficiently, I should have kept the other. I mean, I thought there is one more. Like there are multiple more. That's even more shocking. So let's do that again. Verbose build 0 Clang again, because obviously our build system has cleaned that up already, because it built successfully. No, we don't have it anymore. So that is the new build. We need this for manually installing that too. That is object Clang, object dir. Let's see if this builds relatively. How many resource headers? Do we have that already? That was the name pseudo. Yep. Here is one pseudogen. What was it even? What was the name? Maybe it would have been easier to just disable what doesn't build. I mean, maybe the other Clang option than CMake option worked, because that has at least a different error. It didn't build yet. So surely that probably built in the meantime. Let's do that. No. Let's check already if they have a dedicated CMake option for that too. Oops. That's unfortunate. Just messed up my history. Where was this pseudo thing? That one here, right? Object. I mean, maybe we should actually check how many bin was it that? Maybe we should grab for this host tools thing and CMake files in the whole project. Yeah, here's another host tool. So that is Clang pseudogen. I can't mix this shit up. This is ridiculous. Yeah, and then when you're wondering our T2 Linux, of course, if you're wondering, we do T2 Linux here, right? The increasingly reference and all increasingly reference just working because we fix such stuff, and mostly cross-compiling of all the base infrastructure, including Wayland, Mesa, XFCE, Firefox, and so on, all the good stuff. And certainly the last Linux distribution you will ever need because we fixed everything for you. So gen thing here or here, so basically, I guess, okay, so basically this is Clang proper, and then we can add that here, so like we can list all of those here. This is also, what was the name? Okay, we have two things here to tackle, so the other is use an IDE, they said. Clang gen equals all this good stuff of, here we have it. So we need to, okay, so we have that now, so install that. Okay, let's first save it here, so that would be here. Save, Clang, pseudogen, root tools, and stuff. I mean, given how repetitive this is, we could, like, if we need this now 3 times, we could actually define a variable for that, like save that. At least part of this relatively long root toolchain toolsdir spindir string here. Pseudogen, so we need to copy that, so that is still here of that thing here. So bin, install bin Clang tidy confusable Clang pseudogen. Here we can so save that too, copy that here, and basically test that here. So that is the stage level, not to confuse that, right? Yeah. So wait, do we? I think I delete all of this in this object here. Maybe even basically everything but this T2 mixing. Let's run this manually just to potentially save a minute or two. All right, we need to, okay, this did not serve us much. We need to run it with this additional string pseudogen. So this is just manually pre-testing. I mean, in this case, it doesn't really save us much time. We could, in the meantime, theoretically grab this tree for more host tools. Set up probably that one. Let's see how many. We basically only need to grab that in Clang Tools Extra. Okay, are these all? These are two, and okay. Yeah, so this is only, so that should work. So it should be all. Famous last words. Fingers crossed. Yeah, that is what's keeping the open source stuff together. So yeah, I find it really low quality, right? I would never implement it like this. Maybe, I mean, certainly compiler geniuses have implemented it like this. They probably have good reasons. Maybe it's technically highly difficult to do differently. I don't really see it like this. Maybe they rather do it in C++ as cross-compile inconvenient as it is. But yeah, in the end, only embedded and other bootstrapping operating system bootstrapping people do it like this. It's not even only embedded. Theoretically, it's also like if you ship that for an operating system like macOS and you cross-compile it on Apple Silicon ARM for still supporting last-gen Intel Macs, it would even be relevant for people at Apple for their Xcode integration potentially. So it's not like it's only us, like it's all embedded use cases. Although, yeah, of course, even for embedded use cases, you don't ship Clang language servers and stuff. But so maybe at the end of the day, we are such special snowflake unicorns of cross-compiling all our operating system stuff on highly efficient, epic, thread-ripping Ryzen things for PowerPC Spark, and there, of course, you want your Clang daemon and your Clang code tidy thing. That's probably working now. I hope you enjoyed this, learned something. It's just another shed of light into the dark corners of flagship low-level virtual machine code infrastructure integration and all the efforts required and why there is so much code like that. T2, our amazing Linux distribution, is package format is very codeless. So actually, for normal packages, you need zero code, like stuff that make installs, configure, make installs, CMake, Meson, Ninja, right? But the more code is in T2's package, the more quirky it is, and that is just certainly nicely structured in for what case, at stage, toolchain, bootstrap and stuff, for what use case you need something. And that is certainly why more and more, especially embedded virtualization and container people, start to switch to T2 for all this amazing package enablement and highly automated, maintainable package metadata. I hope you enjoyed to learn something. Don't forget to share, like, and subscribe to support all this. Maybe don't delay, try the last Linux for everything you will ever need. And I hope you enjoyed this, learn something. Maybe go out, fix some bugs too, or send some patches. Patches welcome, especially if you want to figure out if it's possible to build this without the surrounding Clang stuff. Maybe it is not possible. I would prefer this in a dedicated package, but might be hard or impossible. Patches welcome, and I hope to see you soon for all the next fun stuff. RISC-V, and like multi-thread RISC, epic thread ripping RISC-V stuff, and other vintage and retro embedded goodness to come.